Hey Veronica, I'm going to go through this page 32, your lesson activity with you. So we're talking about Esther saving for college. Now, if she deposits $50 per month at the end of the month, how much will she have saved by the end of 12 months? So because it's $50 each month, it's just a linear problem. $50 times 12 months. So she would have $600 at the end of that. Now this is where we get to the geometric sequence and series. So here she's going to put it in a savings account. The annual interest rate is 3.6% compounded monthly at the end of each month. So she's going to put in $50. What will it be worth at the end of the year or 12 months? Now here we're going to look back at a formula a few pages ago. Now I'm going to rewrite this to be a little bit simpler. So what you can really say is that the amount someone saves is equal to the principal, so how much they put in, times 1 plus, now in this case we're going to have 1 plus your monthly rate to the power of the number of months. Okay. So it's the same thing that they're talking about here, but it's a little simpler specifically for a monthly rate. So we're going to be using that. Let's go back. Okay, so now here, let's note a couple things that they tell us. Keep in mind the first month she deposits $50, so the interest will only be compounded 11 times, okay? So we just found her interest rate per month is, I didn't actually show you that yet. 3.6 divided by 12 months is going to give you 0.3%. So 0.3% is her monthly rate. And so now we're going to use that formula, S equals P times 1 plus the monthly rate times number of months. Okay, so now when we use this, we're going to plug in the 50. 1 plus, now her monthly rate is 0.3%, but that gets changed to a decimal by moving the decimal place over 2 times, filling it in with zeros. So we get 0.003 is our rate, 0.003. And then the number of months was 11. So we're going to have 50 times 1.003 to the power of 11. So you're going to use your calculator for that, but that should be pretty easy. Now down here it says complete the table to represent how much individual monthly deposits of $50 will be worth at the end of 12 months. And we're going to write it as A, so that's your starting amount, times 1 plus your rate times the number of months. So here they already gave us the first one. So when we deposit $50, it can get interest for 11 months. So that's why there's an 11 up here. Now, if we put $50 in during the second month, then she's putting in $50. The rate is the same. But now there's only 10 months that she's going to be getting interest because she's starting in the second month. And if we're going all the way to 12, then there's 10 months of gathering interest. It pretty much goes down the line where we're going to be reducing this exponent by 1 every time because now there's only 9 months to accumulate the interest if she puts it in the third month. So you're going to keep filling that up. This whole part's going to be the same, but the exponent's going to be decreasing by 1. Now, when we write it as a sum, let's go ahead. I'm going to show you what this last one's going to be first. So the exponents on all of these are going to go down by 1. So we're going to have 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And this one will be 0. So this one here is going to be 50 times 1.003 to the power of 0. Well, 1.003 to the power of 0 is just 1. Anything to the power of 0 is 1. So this is going to be 50 times 1, which is just 50. So that's going to be our last one here. And that makes sense, right? If you put $50 in it the last month, it's not going to get any interest yet because you're stopping then. So for this part here, if we want to write it as a sum but in reverse, then we're going to have 50, because we're starting at the bottom, plus 50 times 1.003 to the first power, plus 50 times 1.003 to the second power, and so on, okay? So, wants you to use the formula for the sum of a geometric series to determine the amount of money. So we're going to write this out. And if we go back to a different page in your tutorial, page 14, this is how we're going to write it out. So we have our first term, which in this case is going to be 50. Where'd my mouse go? Common ratio is 1.003. Number of terms is going to be 12. So we're going to write that as a series here. Okay, so like I just said, A is 50. Okay, so we're going to be the sum of 12 terms is equal to, we're starting with 50, our rate is 1.003, K, now K is starting at 0, right, because that was our last thing in our table, the exponent was 0, and we're going up to 11 because that was the biggest exponent in our table that we went up to. So now, if we plug this into the formula, we are going to get 50 times 1 minus 1.003 to the power, of 12 up here, over 1 minus 1.003. Now that's a formula in your tutorial, and once you solve that, you will get your answer. Alright. Okay, now here, she wants to be able to save $3,000 in 2 years. What fixed amount is she gonna have to put in? So we have to figure out what we don't know. What we do know is that the sum after, not 12 months, 24 months, right? 2 years is 24 months. So the sum, let's just start over. The sum after 24 months is going to have to be equal to 3,000. What we know that the same rate of 1.003 is in effect. So what we don't know is A, how much she's starting with. So we're going to set it up as an equation. 3,000 is equal to A times 1 minus 1.003 to the 11th power over 1 minus 1.003. And you're just going to solve this for A now. Okay, so this is what I'm using right here, by the way. And now for this last part, it should be pretty easy. You're going to substitute in what it tells you. So it says substitute P for the value of A. So we're not using any numbers here pretty much. We're just using variables. So P is going to go for A, and then 1 plus I is going to go right here for the value of R. So that should be pretty easy to just substitute in there, and you don't have to, it says simplify, you don't have to really solve anything. There's not going to be a number that you're going to get, you're just going to simplify the equation. By the way, this was what I was referring to when I took our notation like this and I put it into this formula of how we actually solve it. So the sum was equal to A times 1 minus the rate to the power, that's up here, and then 1 minus the rate. So this is where I got that.